Okay, hello everyone. Let us now do some additional exercises on quadratic functions. So let's answer this first set of questions. So create a quadratic function in general form based on the given vertex or intercepts. Okay, so we have here a vertex 1 and 2 and passes through 0, 0. Okay, so it is like the given are like from the previous exercise that we did in part 1 of quadratic functions. So the only difference is that we saw that from a graph, but here we are not given a graph. We are just given the vertex coordinates and also another point that is intersected by the graph, which is 0, 0. So let's do the same procedure. So for A, we have here our vertex 1, 2. So using the standard form, we can do this. A multiplied by x minus 1 squared plus 2, right? So finding A, so we use the point, use 0, 0, and then substitute. So 0 is equal to A multiplied by 0 minus 1 squared plus 2. Okay, so what do we get? A multiplied by negative 1 squared, that's 1, plus 2. So we will get A is equal to negative 2. Okay, so that's negative 2. And then we can then substitute it. We can substitute it to our function right here. So negative 2 multiplied by x minus 1 squared plus 2. Okay, so this is our quadratic function. Okay, so if it wants to, uh, in the question, it is stated that you must convert it to general form. So we also know how to do that already. So negative 2 times x squared minus 2x plus 1. And then you will get plus 2. So y is equal to negative 2x squared plus 4x and then minus 2 plus 2. So this will be uh, 0 and then a negative 2x squared plus 4x. So this is our quadratic function in general form. Okay, let us now do this second example. We are given here x is equal to 2 and x is equal to negative 4. So these are our roots. Okay, so if we recall, in finding the roots of a quadratic equation, let's say for example, if we are given um, x squared plus 4x plus 4 is equal to 0. So what do we do here? We factor this one, right? So we get x plus 2 multiplied by x plus 2 is equal to 0. And then we use the zero product property. X plus 2 is equal to 0. And then x is equal to negative 2. So x is equal to negative 2 is also the same. So this is our root. So negative 2, right? Multiplicity of 2. Okay? So what we are doing here, what we're going to do for this second problem is we're going to do this in reverse. So we are given the roots, and now we are going to find the equation. So as you can see here, the root is negative 2. So so this is x plus 2. So as you can see here, right, this is x plus 2. So x plus 2 in the same here. Okay. So we are going to do the reverse of that. Okay. So we are given the roots of x is equal to 2 and x is equal to negative 4. So okay, we have here y is equal to, this will be x minus 2 and then x plus 4. Okay, so we can then multiply those two. We will get x squared plus 4x minus 2x minus 8. Then we will get x squared plus 2x minus 8. So this is now our quadratic function given the roots. Okay, so yeah, so let's proceed to different problems. So we have here, find the vertex, axis of symmetry, and zeros. Zeros are roots of the given quadratic function. Okay, so we have here, as you can see, this is a general form, right? So there are two approaches in order to answer this A. Okay, so we can derive the formula for finding the vertex. So we can do that before answering. So we recall that we have a standard form and a general form, right? So a standard form is A multiplied by x minus h squared, then plus k. And then this is also equivalent to our, what do you call this, general form, right? So we have ax squared plus bx plus c. So let's evaluate the left hand side first. A multiplied by x squared minus 2hx, and then plus h squared plus k is equal to ax squared plus bx plus c. You will get ax squared minus 2ahx plus ah squared plus k is equal to ax squared plus bx plus c. Okay, so we have it right here. So let's do a coefficient comparison. So if this is to be equal, if this equation is to be true, then we can say that b right here, the coefficient of x on the right hand side, should be equal to the coefficient of x on the left hand side, right? So b should be equal to negative 2ah. So therefore, h is equal to negative b over 2a. Okay, so that is the formula for the x coordinate of the vertex. So how do we find the formula for k? Okay, so we also have here another uh, coefficient comparison. So in order for this equation to be true, to evaluate to true, c must be equal to ah squared plus k. So let's now find k. K is therefore c minus ah squared. So you have h right here. So let us substitute. We already have h. So substitute it here. So k is equal to c minus a multiplied by negative b over 2a squared. So what do we get? We will get k is equal to c minus a multiplied by b squared over 4a squared. So we can cancel out this a. And then we have c minus b squared over 4a. Okay. So you can just memorize this formula, and then you can use it to solve the problem. Okay, so let's erase this first. Oh, let's copy it. Copy. And let's place this formulas in here. Okay. So let's use that. Let's use this. So we have here x squared plus 4x plus 3. Okay, so what is our the for let's apply the formula of the vertex. So h, we have here h is equal to negative b over 2a. So what is the b in the equation? That is 4, right? Negative 4 over, and the a is 1. 1 multiplied by 2. Okay, so here we get h is equal to negative 2. Okay, so that is h. Then k is equal to c minus, let's substitute it directly. So c, what is the c here? We have here 3, right? Minus b squared, that is 4. 4 squared over 4 times 1. Okay, so what do we have here? 3 minus 16 all over 4, right? Okay, so that is equal to 3 minus 4, so that will be negative 1. Okay, so our vertex is at x, I mean vertex is at negative 2, and negative 1. Okay, so that means also that our axis of symmetry is x is equal to negative 2, right? And the zeros, so how do we find the zeros? So to find the zeros, we can factor this out, okay? So we have here, so this is x squared plus 4x plus 3. So if you're finding the zeros, so the zeros are the x-intercepts, right? So the y for that, for the x-intercepts is 0, right? So you can then factor this out. So we have x plus 3 and then x plus 1 is equal to 0. Using the zero product property, x plus 3 is equal to 0, x plus 1 to 0. We have here x is equal to negative 3, then x is equal to negative 1. Okay, so these are the zeros. So there you have it. We've solved letter A. Okay, so you can also do another, there is also another way to find the vertex. So let me show you that. There is also another way aside from that. If you don't want to memorize formula, then you can use this. So we can use completing the square. Okay, so we have here f of x equal to x squared plus 4x, or let's just put y here. Let's just put y is equal to fx plus 3. So we can do completing the square. So x squared plus 4x. Then what is, in order to complete the square of x squared plus 4x, so we add 4 over 2 and then square that, right? Plus 3. So the same thing we do for the other side, 4 over 2 squared. So we will get this is y plus 2, right? I mean 4, y plus 4. So we have here x squared plus 4x plus 4 plus 3. Okay, so we have here y plus 4 is equal to, so let's express this as a square of a binomial. So we can say this is x plus 2 squared, right? Then plus 3. And then subtracting 4 from both sides, you will get y is equal to x plus 2 squared plus 3 minus 4, that would be negative 1. So this is now our standard form, right? So this is now our standard form. So we can then say that our h is equal to negative 2 and k is equal to negative 1, right? So why is h negative 2 here? You're given x plus 2. Because if you recall, our standard form is a times x minus h squared plus k. So it is minus h here, so this is minus 2. Okay, so that's another way. And yeah, it's really cool. Okay, so let's answer letter B, the second item. Let's answer letter B. So letter B, so we have here g of x is equal to x squared minus 4. So how do we find the vertex? Let's use the formula for that. So how do we do that? H is equal to, what is our B here? As you can see, our B is 0, right? So our H will be automatically 0. So how do we find K? K is equal to C. Our C right here is negative 4, right? Negative 4 minus B squared over 4A. As again, our B is 0. So this will be 0. So K is equal to negative 4. So there you have it, our vertex. So vertex is at 0, negative 4. And then our axis of symmetry is x is equal to 0. Okay, x is equal to 0. And then, so that is basically the y-axis. And then what do you have? And the zeros. So zeros, so x squared minus 4 is equal to 0. And then we have here, So this is just equivalent to, so x minus 2 and x plus 2, right? So you will get, using the zero product property, x minus 2 is equal to 0, x plus 2 is equal to 0. So this x is equal to 2 and x is equal to negative 2. So these are our zeros. Okay, so that's it for this video. I hope you learned something. Uh, Thank you for watching and see you in the next videos.